We open this series by proposing that the enormous possibility space created by artificial intelligence can become a source of cognitive overload. Rather than helping us accomplish tasks, AI often leaves us navigating interfaces, prompts, and an ever-growing number of choices. To address this, we deliberately adopted the opposite approach. Instead of maximizing possibilities, we progressively defined a rigid set of design constraints intended to reduce the user's cognitive footprint. Each constraint forced us to make trade-offs, but together they formed a coherent design philosophy. Today, we reach the final step of that journey. We now have a complete solution, and our objective is simply to evaluate it against the design constraints established throughout this series. The use case is intentionally simple. Every morning, the system prepares a short podcast covering historical events that occurred exactly 100 years earlier. It retrieves factual information, reasons over the available sources, writes a complete narrative, and makes it available before the day begins. Let's begin with the experience rather than the technology.
The Northern Expedition, launched on July 9th in 1926, marked a pivotal moment in 20th century. The Northern Expedition, launched on July 9th in 1926, marked a pivotal moment in 20th century.
What you are listening to was produced automatically during the night. By the time I wake up, today's episode already exists. The script has been synchronized through iCloud and is immediately available from the applications I already use. There is no prompt to write. There is no interface to open. There is no workflow to launch. There is only one action. Press play. Behind the simple interaction is a local visual workflow designed with Langflow and executed automatically on a schedule. The workflow uses Allama to run a local Quen language model for reasoning, while a search tool retrieves the information required to build each episode. Together, these components retrieve knowledge, reason over the results, generate the podcast script, and publish the finished artifact. The workflow itself remains deliberately small. It defines the task, coordinates retrieval, delegates reasoning, publishes the result. The workflow expresses intent. The runtime performs the execution. Every night, the workflow executes locally for approximately 90 seconds. During execution, the system draws an average of 20 watts, consuming roughly half a watt-hour of energy before returning to its idle state. The workflow produces text. Apple's native Siri, text-to-speech engine, renders that text into speech live at the moment it is played. The workflow produces the knowledge. The operating system delivers the experience. This distinction is important because it allows us to evaluate the solution against the design constraints established throughout the series. The first two constraints, hardware and model, were addressed in the previous episodes. We demonstrated that capable local reasoning is now possible on practical, affordable hardware while remaining within a modest power envelope. This final evaluation therefore focuses on the remaining two constraints. Interaction. The workflow completes its work before the user arrives. There is no prompt to write, no application to configure, no workflow to monitor. The complete experience has been reduced to a single action. Press play. Consumption. The podcast is delivered through an application that already belongs to my daily routine. Rather than introducing another AI destination, the system integrates into an existing consumption surface. The artifact appears exactly where it is naturally consumed. Taken individually, none of these technologies is particularly remarkable. What becomes interesting is their composition under a single set of design constraints. Rather than optimizing for the largest model, the fastest benchmark, or the greatest number of features, the objective becomes minimizing the effort required from the user while preserving meaningful outcomes. This is the central idea behind the lower cognitive footprint AI.